This is a lecture on 3-2, measures of variation. We're going to start with the definitions. So 3-2 is a continuation of 3-1 because in 3-1 what we were measuring is the measures of central tendency. Where is the middle? The measures of variation is the measure of the spread. So you know where the middle of the data is? The question is, how does it spread out? How far to the left and to the right of the mean it goes? So the first measurement is the range. And on the next video, we'll jump to Excel. And I'll show you how to do all of this in the same example as we did in 3-1. So the range is the highest value minus the lowest value. There is no special labeling for the range. Now, the variance and my next definition, the standard deviation, those are the formulas that we actually want to calculate. A standard deviation measures how far the data is, how spread out the data. We will be using standard deviations to kind of move away from the mean, and there is a special special formulas, special theorems and methods on how the standard deviation is related to the average and all of the x's within it if you know the distribution. So if you know that you have a bell shape, if you know that you have a normal distribution, and this is what we're going to concentrate on this semester. If you know that you have a normal distribution, this standard deviation right here, the formula, the standard deviation will actually tell you a lot of things. So before getting into how to use the standard deviation, 3-2 explains how to calculate it. So let's start with vocabulary. There is a population and then there's a sample. So we're going to start with the population. In order for me to find the standard deviation, I need to find something called the variance. There is no we're not using variance per se. What it is, it's the sum of the differences of each x from the mean, squared. The reason why we need to square it is because sometimes x is smaller than mu, sometimes it's larger than mu. If you start adding positive and negative numbers, they disappear. So what do? We square this. You find an average of these distances, and this is called variance. We're labeling this with the Greek letter sigma. So let me do it over here. Under insert, you're going to click on equation. Right here in script, if you click on the script, what you will see is you have a place of putting your squares. It's called a superscript. What I'm going to do is I'm going to click over here. I need to find a letter called sigma. A sigma is the Greek letter. So under basic math, so let me do this right here. On this menu right here, click on the arrow, and it should be under basic math. So if you're not under basic math, click on it. You can also click Greek letters. It will just isolate the Greek letters. They are in alphabetical order. Sigma happens to be, I don't know, equivalent of, let's say, an S. So it's towards the end of the alphabet. You're going to click on that one and the square. This is a symbol for population variance. Now, the sigma, that's the one that I'm actually interested in. That's the standard deviation. The sigma is the population standard deviation. Let me show you where to find it again. Insert, equation, click, it's right there. I'm just unbolding it. And the formula is the square root of the variance. So we're finding the variance, you're taking a square root of it, you have your population. The only difference with a sample is, so there's two differences in the sample. First of all, because this is a population, I have a large N on it over here. But the sample has a little n and the -1. So what it does is if you have a small enough sample, let's say 10 or 15, which is what we're using in this class for homework, you'll actually notice there's a big difference whether you treat that 15 as a population or if you treat it as a sample, because the difference is you're just dividing by that 15 or you're dividing by a 15 minus 1. So the calculator and Excel and all of your calculating devices do not know whether whether your data is a whole population or a sample. So what it's going to do, it's going to spit out both. You need to pick which one you want to use. The second difference is the sample variance and the sample standard deviation has different notation. All we're going to do is label it with the letter S. If I want to make it look like over here, I'll just do italic font. That's it. So this is an English letter versus a Greek letter. So it's much easier to find it. This one I will go into insert because in order for me to do a variance, I need to have S squared. So remember, population, I'll go over it in a second. So let me type this in. I need accents. No, not accents. I need script squared. Moving over, S squared and unbold it. All right, so let me review this for a second. Population variance, sigma squared. Sample variance, S squared. Population standard deviation, sigma. Sample standard deviation, S.